This time, let's now proceed to permutation. The number of permutations of n objects taken r at a time is determined by the following formula. N factorial over n minus r factorial. Let's have the following example. A code of 4 digits in a specific order. The digits are between 0 to 9. How many different permutations are there if one digit may only be used once? Based on the given, our n here is 10, which represents for the 10 digits from 0 to 9, while our r is 4, which represents for the 4-digit code. Substituting these in our formula n factorial over n minus r factorial, we have 10 factorial over 10 minus 4 factorial. Solving 10 minus 4, this will give us 10 factorial over 6 factorial. 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 factorial, which is equal to 6 times 5 times 4 times 3 times 2 times 1. We can cancel the numbers in the numerator that is the same with the denominator, and these numbers are 6 times 5 times 4 times 3 times 2 times 1. And the remaining numbers we have 10 times 9 times 8 times 7. Multiplying them together would give us a result of 5,040. Let's have the next example. 5 persons are to be seated in a 12-seater Toyota GL Grandia. In how many ways can they be seated? In here, our n is the 12 seats for the Toyota GL Grandia, while our r is 5, which represents for the 5 persons. Substituting this in the formula, we have 12 factorial over 12 minus 5 factorial. Solving 12 minus 5 would give us a result of 12 factorial over 7 factorial. This is also equal to 12 factorial, which is equal to 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 7 factorial, which is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. Same process with the previous example, we can cancel the numbers in the numerator that are the same in the denominator. And these numbers are 7 times 6 times 5 times 4 times 3 times 2 times 1. And we have the remaining numbers 12 times 11 times 10 times 9 times 8, which is equal to 95,040. If you're using the calculator on the left side of your screen, all you have to do is, for example, to get the permutation of 8 taken 4 at a time, or 8p4, just simply press 8, then press shift times, press 4, then equals. Then the calculator will give you the correct answer. However, if you're using the calculator found on the right side of your screen, all you have to do is to press 8, press Shift and CR, press 4, then equals. Let's now proceed to distinguishable permutation. By definition, distinguishable permutation is the number of different permutations of n objects where there are n sub 1 repeated items, n sub 2 repeated items, until n sub k repeated items. We have the given formula n factorial over n sub 1 factorial times n sub 2 factorial until n sub k factorial. The numerator n sub k factorial represents the total number of items, while the denominator, the n sub 1, the n sub 2 until n sub k, represents all the numbers or all the items that repeats. Let's have this example. How many distinguishable permutation exist for the letters in the word Philippines? Note that there are 11 letters in all in the given word, which is the Philippines. Let's count how many are repeated letters. We have P, H, I, L, N, E, S. Let's count how many P's are there. We have 1, 2, 3. 3 P's, 1 for H, 3 for I's, 1 L, 1 N, 1 E, and 1 S. Substituting it in the formula, we have 11 factorial, which is the total number of letters in the word Philippines, over the letters that repeats. We have 3 factorial times 1 factorial times 3 factorial times 1 factorial times 1 factorial times 1 factorial times 1 factorial. Or you can only have 11 factorial times 3 factorial times 3 factorial. We will not include 1 factorial because 1 factorial is equal to 1. Solving this one would give us an answer of 1,108,800. Let's now proceed to the second example. Find the number of ways of placing 10 balls in a row given that 4 are red, 3 are blue, 2 are yellow, and 1 is green. So again, based on the given, we have red, blue, yellow, and green balls. There are 4 red balls, 3 are blue, 2 are yellow, and 1 is green. The total number of balls we have 10 when you add 4 plus 3 plus 2 plus 1. Substituting in the formula, we have 10 factorial over 4 factorial times 3 factorial times 2 factorial times 1 factorial. Solving this one would give us a result of 12,600. Let's now proceed to circular permutation. If n objects are to be arranged around a circle, the number of permutation of n different things is, you have the formula, n minus 1 factorial. The number of permutation of n different things around a ring and the like is given with the formula, n minus 1 factorial over 2. Let's have the first formula. In how many ways can 8 people be seated in a round table? So the given problem is referring to a round table. So we will use the first formula with n minus 1 factorial. Our n here is 8. Using the formula n minus 1 factorial, this is equal to 8 minus 1 factorial, which is also equal to 7 factorial, and that would give us an answer of 5,014. Let's have the next example. How many ways can we arrange 6 distinct keys in the circular key ring? Using the formula n minus 1 factorial over 2, our n is 6, which represents the 6 distinct keys. We have 6 minus 1 factorial over 2. Solving this one would give us 5 factorial over 2, and that is equal to 16.